day 6 now in geometry, and today your practice quiz is also going to be like your exit ticket. So the last exit ticket for this week was yesterday, day 5. For the rest of the week, all that is due is this practice quiz and the quiz itself. I am just grading your practice quiz based off of you completing every question. I'm not going to go through and make sure you did it right. You doing it right is your way of studying and making sure you know how to do these things. But we're going to do them together today. So today is a great day to ask questions if anything you're not sure about, because our quiz is tomorrow. So our Unit 1 quiz starts with number 1. It says measure the line segment in inches. That part we don't need to worry about. We didn't focus as much on measurements. Now, you could do that just for fun if you like, but for now, everybody on your practice quiz, I'm going to cross this out, and we are mostly focused on constructing the perpendicular bisector. So I'm crossing that off. So for our perpendicular bisector, we will need a compass. And you will also need some sort of straight edge. It could be your ruler, or you could go ahead and get your protractor out and just use the flat edge as your straight line. And whenever we construct a perpendicular bisector, I'm using my point. Where should I place my point first?
On the right, at the end of the line on the right bottom.
Yeah. You can go ahead and put the point on the end of the line segment. You could do it on either side. And how big does this need to be open?
A little over halfway.
A little over halfway. So right here, it looks like I'm over halfway, but if you just want to be sure, it is always better for it to be a little bit big than a little too small. Because if it's too small, your arcs are not going to cross each other. So I'm going to turn my paper to the side just because I think I have an easier time when my line is flat. Put my point on the end, and we want to create an arc that goes under the line and over the line. Big half circle. Remember, when you hold your compass, it's always going to be a little better if you're focusing on just holding the metal part. Don't use too much pressure. The pencil is the only part that moves. Keep your point in the same spot. And there's my first step. Once we've got that first arc, where do I go next?
To the other end of the line.
To the other end of the line, right here. Okay. And what am I doing now?
You're going to do the same thing.
Yeah, same thing. The important thing that we're looking for is where the arcs cross, where they intersect. So you could even just put marks where it would intersect, or you could just redraw that whole arc like this. Now, the size of your compass for the second arc is very important.
Is it the same?
Yes, it needs to be exactly the same size as your first arc. So if you need to go back and measure, if you need to look at these little marks on the edge and make sure that it's on the same measurement beforehand, do that. And after you've drawn both, it's a good idea to just triple check. Keep it open at the same distance. That matches. That matches. These are the same. So once I've got my two arcs, what do I do from here?
Draw a line where they touch.
Yeah, now we want to draw our line using a straight edge, and that should go through the intersections we created. It should go through these little points where the arcs meet. So I'm going to line that up as close as I can and draw a line going through like that. And there's two little things, or kind of three little things left that I need to mark on this.
We're gonna make a box.
Yeah.
Inside,
We need a box.
and then we're gonna have, I forgot what they're called, but two little slackers, one on each side of the line.
Good. Two little tick marks. That shows that we have split our segment in half. So, if you're worried you might forget that, maybe highlight them in a different color so that you see them and don't forget. And if you want to create like a little checklist for yourself, this part is optional. There's 3 points that I'm looking for whenever I grade this. The first thing I'm looking for is that your line actually goes through those intersections evenly. Evenly, yes. Now you see how mine is ever so slightly off. That's okay. Sometimes these pencils aren't as pointy as they could be. It might be a tiny bit off. Now, if your line was like way over here, you'll get that wrong. Make sure it goes as close as you can get it going through. So that's where you'll get one of your points from. The other point you'll get is for the box. Having the box in there matters. And the other point you'll get is from the tick marks. So make sure your line goes through the intersections. Make sure you have your box. Make sure you have your tick marks. Those are the 3 things I'm looking for. So I see that and I say check, check, check.
Just so I don't forget, that's a 90-degree angle as
Yes.
far as that box, right?
Yes, that box means 90 degrees. So if you want to make a little note to the side, you can write box means 90 degrees. And that would be a good thing to take note of because you may have an angle on your quiz that's marked with a box, and you'll need to know that that is a 90-degree angle. Okay. A few people still making their bisectors. So I will give us another minute or so to finish that up. And then we'll go on to number 2 and make sure if you have any other questions, you let me know before we go on. All right, so for number 2, you're gonna need your protractor. Now we're gonna measure the angle to the nearest degree. And if you remember, we need to use, say it again.
Yesterday you was talking about the backwards one.
Yes, the backwards angle. So there's 2 ways your angle might face. It could be facing to the left.
And that means outside.
Yeah. Or it could be facing to the right. Yes. And whenever you're looking at your protractor, you'll notice we have numbers on the inside and we have numbers on the outside. So if my angle is facing left, we can see. Yes, we want to use the outside numbers because the outside numbers, when I'm facing left, start from 0, 10, 20, 30, 40, right about 50. So what would our answer be for number 2?
50.
C, 50 degrees. So
This time it is backwards.
Yes, this time it is backwards. So if your angle's facing left, we'll make a little note here. We use the numbers on the outside. If your angle is facing right, we use the numbers on the inside. Yeah. I tried. I tried my best.
Charles, we low key twins right now. I should have worn me a little black.
Yeah.
Right.
I could have been baby Charles.
Yes.
20.
Yes, 20 Anthony. Come on, again.
Oh, man.
We're speaking in brain rot, and
I love it.
it's everything for me.
Okay. Any questions on number 2? Okay, are we ready for the next page? Yes.
Yeah.
ma'am.
Oh,
Right.
sorry.
Yeah, go ahead.
Do we have to put the little art on that part there?
Oh, like label it?
Yeah.
You don't have to. You just have to tell me the
What
measure.
angle? Yeah.
You could if you want, but you don't have to.
Got
Okay. So flipping the page, we're gonna go to page 2, and now for number 3, we're constructing the angle bisector. So we will do the same thing. We're gonna give ourselves a step-by-step guide. And let's actually create that guide over to the side before we construct it. There's gonna be 4 things I look for on this one. And I'm gonna list those out for you. 1, 2, 3, 4. So the first thing I'm looking for is that on your angle, you have arc number 1 that you draw. And I'm gonna highlight that with the red. The next thing I will look for is that your arc number 2 and 3, once you create these points here, you're going to have 2 and 3 make an intersection in the middle in some way. So that's arc 2 and 3. So there's all 3 arcs. The next thing I'm looking for is that your line going in the middle right here, your actual bisector, crosses through arcs 2 and 3. So crosses through arcs. And the 4th thing I will look for is that once you've done all of that, you put something like arcs. You could do 1 or 2 arcs, or you could do a million. I wouldn't do that. Show that your angles are equal. Angles are equal. So these are the 4 things I'm looking for when we do this. So I'll give you guys a minute to write that list down. I'll tell you in the past, whenever I've graded these quizzes, the people that have this checklist on their practice quiz always do better than people that don't write the checklist. There's no tell, I promise. They really do. So, pause for this one to help us. So, opening my screen up just a little bit here. Where does my point go first?
At the vertex.
At the vertex. Good. So we want to put our point on the vertex. Now, I find that for me, like this is kind of an awkward angle to be holding my hand at. I'm going to turn my page a little bit so that whenever I'm holding my compass, my pencil is in the middle of my angle. To me, this makes it easier. Could be different for you. And am I drawing this first arc inside my angle or outside?
Inside.
Inside. It needs to be inside the angle. Like that?
Yes.
Do I need to go any further?
Yes.
I do. We want to have that arc inside the angle, but we do still want it to cross those rays that make up the angle. So inside the angle, but still crossing the lines.
No, we are setting it a little bit out. No, about what do you set yours at? About 1.5.
So I have mine open a little over the 1, maybe 1.5, 1.25-ish. On here. And if I were to measure that with a ruler or with like here's just a ruler on the edge of here, from my vertex to the arc, it's about 1.25 inch. That's about how big I had it open. So there's my first arc, and now where do I go?
So, use your side.
Yes, my sides, my points,
Yeah.
those intersections. Wherever I cross that arc to the ray that makes up the angle, that's where my point goes next. Now, at this step, you could open your compass a little bigger if you want your arc crossing farther out. You could keep it the same though. I'm just going to keep it the same. And we're going to make an arc going inside the angle again. Just like that. It doesn't have to touch the middle arc, but it's okay if it does. It just depends how big you open it. So there's arc number 2. Now what? Yeah, just put the point on the other intersection right here. And we're going to cross that arc like this. So I've got that. Arcs 2 and 3 are done. Yes, now we draw our line. So get your straight edge. Our line should go from the vertex through that last intersection. Try to line it up as close as you can.
Go straight through that,
Yes.
next,
I'm gonna put a little arrow at the end of that.
Perfect.
Yes. And what is my last step?
Put your lines on the outside.
Lines on the outside. What do you mean lines on the
What
outside?
do you call them? You have 2 steps.
Oh, the arcs. Is that what you're
The
talking
arcs.
about?
Yeah, see right here? Number 2, go to number 2 where you put the arcs. Then
Uh-huh.
you put your little lines right here.
She's talking about the tick marks.
The tick mark.
Okay.
Oh,
Yeah.
okay. So on your perpendicular bisector, we do use tick marks because we're showing that the line segments are equal.
Okay.
But on the angle, to show angles are equal, we don't use tick marks. We use arcs.
Okay,
So-
this one.
Yes. So for this one to show they're equal, we're gonna do that 4th box that I gave you, where I put an arc on each of the 2 angles we just created. So that would be like, here's an arc,
Yeah.
here's an arc. I could do that. Some people like to do 2. Either one is fine.
That's what had me too, though. I was thinking we had to use it because we put it on the number 2.
Gotcha. Are you thinking about these little marks that I wrote?
Yeah, the tick
Yeah.
marks.
Oh, okay. So here, this might be less confusing. I just didn't want to highlight that arc too much. It was just showing the
that's
ends of that
smart.
first arc. See that? Yeah. Okay.
So creative.
Oh, man.
I never thought to do that.
Okay. Okay. Any questions on that angle bisector? You think we got it?
You like a cook when it comes to math.
Yeah. Okay. Alright. Let's go ahead and move down to our angle problems now. And now we're going to be setting up some equations. So, whenever we have these different sets of angles here, something that I find helpful is keeping kind of a little guide of the different things we might see. So for example, I'm going to get a sticky note out. I'm going to draw a few little things to help me. And the first thing I'm going to do is I'm going to draw a straight line, and I'm going to stick an angle so that I've got 2 angles on a straight line. What would these 2 angles add up to?
180.
180. So it might be a good idea if you make a note that these equal 180 degrees. Another situation we might run into is something like we have a point And then we have some random angles that maybe go all the way around. When it goes all the way around, how many degrees is that?
360.
360. Good. Then I'm going to draw two lines to make an X like this. And I'm going to put an arc on the top angle and on the bottom angle. Now, I don't know the measure of these angles here, but how do we know these two angles are related to each other?
The arcs.
The arcs do tell us, but there's also a special relationship that happens when angles are across from each other. They're equal.
Oh.
Equal. So I'm not going to write equals a number. I'm just going to say equal to each other. So we have that.
So those are what you call vertical angles.
Yes, vertical angles. Thank you, Diane.
I mean,
Vertical angles. Perfect. Perfect. Now, if you still have, there was a sticky note that we made for angles that we did the circles and we colored them in. If you have that sticky note somewhere in your notebook, that would be a good one to pull out for your quiz. I want to find mine real quick. Somewhere in here. Find my notebook. Oh, it's right here. That's okay. Let's see. Okay, that was from day 2 notes, if you're looking for that. This is the note I'm talking about, the one where we do the parallel lines. This is another one that we may need to look at. And that's where the same color angles are equal.
Yes.
Different color angles add up to 180. Okay? We're going to keep all of that in mind whenever we do the next few problems. So I will wait a moment while I hear us kind of flipping through our notebooks looking for those. I'll pause for a minute. If anybody needs to make a new note, I can wait for you. All right, so now that I have some of my notes ready, let's look at number 4. I have 2 angle values given to me, and I want to solve for x, so we need to write an equation. What equation could I write here for these angles?
X plus 12 plus 147 equals 180.
Perfect. These 2 angles add up to 180, so I'm just going to write the values of those, add them together, equal 180. X plus 12 plus 147 equals 180. I'll draw a line here. Now that my equation is written, how can I solve it?
You add your like terms.
Yeah, let's combine like terms. 12 and 147. What do we get?
159.
159. So I'll bring that down. X plus 159 equals 180.
And then you subtract the 159 from both sides.
Good. Subtract 159 from both sides.
You get X equals 21.
Perfect. X equals 21. And on these, please circle your answers. There's lots of numbers, and it's going to make grading this a lot easier if I can clearly see what your answer is. So circle your answer. And that's number 4. Okay, let's skip that over. And then look at number 5.
360.
Yes, number 5, we have angles around a point. These are going to add up to 360. So let's write an equation. what equation could I write for number 5?
X minus 116
Mm-hmm.
plus 43 plus 287
Good. X minus 116, and then I'll add 43. 287
equals 360.
equals 360. Perfect. Okay, now on this one, we want to be very careful.
Yes.
We want to be very careful when we combine like terms. Why do we need to be extra careful here?
Looks like you have 3 to add.
You do have 3 to add. One of those is special though.
One's a negative.
The ones, yeah.
Yeah.
Negative 16.
This is negative 116. So if seeing a negative you think might mess you up or you might forget, put it in parentheses or something and put a little plus by it. So you know you're adding a negative in there. Don't lose your negative. So whenever I combine these, include your negative in the equation. I'm going to do negative 116 plus 43. Oh. So negative 116 plus 43 plus 287. And then enter. And I got 214. You guys get the same?
Yep.
Yes.
Okay, so it's positive 214. Am I bringing down a plus or a minus in front of that? Plus. Plus. The only reason we would bring down minus is if this was a negative number. Okay, so we have that all adds up to 214. And we bring down x plus 214 equals 360.
And you subtract that 214
Yes.
on both sides.
Subtract 214 from both sides.
Gives you X plus 6.
Yes. Perfect. X equals 146. Perfect. And that is number 5. And again, circle your answer.
Okay, what did I do wrong? 360. Oh.
What did you find out?
Yeah, I put 6 and stuff in 0.
Ah.
It's not good that. Always changing my numbers. So that's
Good
okay.
that you caught it though.
Yes. I turned 360 into 366.
Okay, are we ready for number 6? Do we need more time on 5? Ready?
Ready for number 6.
Let's do it. Okay, number 6.
Yeah.
Number 6, now we have some parallel lines. You know that because of these little arrows here. Highlight those in red. So what should we do here?
40 equals 5x.
You're right. These are going to be equal to each other. 140 equals 5x. Now, if you can't just look at it and tell right away, don't be ashamed if you have to draw some circles. That's okay. I'm going to draw those circles just to show you in case. Here, if I started with the top left, I would do the one across. Same here, top left, color the one across. And we can see these are left over. They'd be the same color. They're going to be equal to each other.
Yes.
Yes. Good. So we can do 140 equals 5x. You could also do 5x equals 140. Either way will work. It just depends on how you write it. You'll get the same answer. I'm going to put my x first, just because I like having my x first. So 5x equals 140.
You can divide by 5 on both
Divide
sides.
by 5 on both sides. And we get x equals
28.
28. Good. And we're done. That one wasn't so bad.
Yeah, it was an easy one.
Nice easy one, yeah.
Some dope.
Okay. So that's number 6. And now we should look at number 7. What do we have here?
The verticals being equal to each other.
Yes, these are vertical angles. They're right across from each other, so they're equal. They're equal. So for number 7, what equation could I write?
10x plus 2
Uh-huh.
equals 152.
Perfect. 10x plus 2 equals 152. Okay. And what could I do to solve it?
Subtract 2 from both sides.
Perfect. Subtract 2.
And then divide by 10.
Perfect. 10x equals 150. And you said we'll divide by 10.
You get 15.
Perfect. X equals
That was an easy one.
15. Guys are getting good at these. Excellent. Okay, so that is all of the second page. I'll leave that up for a minute. Go on to the next. Do you have any questions about anything on page 2? Let's go ahead to the third page. Now we've got 4 more angle problems to solve. So for number 8, what's going on here?
It's the 360 we talk about.
Let's see, is it a 360?
180.
Ooh, is it 360 or 180?
So 180.
Ah, it looked like it might be a
It
360,
just turns
but
sideways.
it doesn't go all the way around. It's just that straight line. So this is going to be 180. What equation could I write?
5x plus 1 plus 69 equals 180.
Yes, 5x plus 1 plus 69 equals 180. Equation is written. Where do we go from here?
You got
Subtract.
1 is 69.
Add the 1 and the 69? Yep, we can combine our like term. Let's do that. And that gives us 70. So 70. Bring down 5x. Bring down equals 180.
Subtract 70
Yes,
from both.
subtract 70. Bring down 5x equals
110.
110. Good.
Divide 5.
Divide 5.
Those x.
Good.
22.
So x equals 22. Perfect. Perfect, perfect. That is number 8. Look ahead to number 9. What's happening in number 9?
360.
Yes, now we have 360. Perfect, perfect. So, for number 9, if our angles are going to add up to 360, what is a good equation? Right.
X degrees plus 116 degrees
Mm-hmm.
plus 4x degrees equals 360.
Perfect. We're just going to add them all together. X, 116, and 4x. You can write those 3 in any order. X plus 116 plus 4x equals 360. And what do I do now?
Add like terms.
Add like terms. All right.
That'd be
Fine.
5, right?
Good. 5x. X plus 4x is 5x
Plus 116,
plus 116 equals
360.
360.
Then you subtract 116.
Perfect. Subtract 116. Bring everything down. 5x equals,
44.
yes, 244. And you will get a decimal for this one. That's okay.
Divide by.
Yes. Divide by 5.
You get X is 48.8.
Perfect. X is 48.8. Good. Good, good, good. Okay. That's number 9. Are we ready for 10? Okay, number 10. What's going on in number 10?
Equals.
They're equal. Good. This one, we have parallel lines again. We could draw those circles and see that they would be the same color, so they're equal. We could also see that they both have one arc. That means they're equal also. Draw the circles just for fun.
Yeah.
Yeah.
Number 8.
And I can see here that if I were to color these, they would be the same color. So they're equal. What equation can I write?
6x plus 4 equals 94.
Perfect. 6x plus 4 equals 94. Let's do that.
That's
Now, where do I go?
You subtract 4 both sides.
Good. Subtract 4 on both sides. Bring down 6x equals 90.
Divide by 6.
Divide by 6.
Equals 15.
X equals 15. Good. Okay, that is number 10. X equals 15. Very good. Okay. Now we've got that one. I think there's just one more angle problem. And that's number 11. So for number 11, what's happening? 180. We have a straight line, a flat line. Remember, we want to draw, if it helps, you could draw that half circle. And we know that that's 180. So, if these three angles add up to 180, what is a good equation I could write?
89 plus 3x plus 1 plus 2x plus 20.
Perfect. 89 plus 3x plus 1 plus 2x plus 20
Equals 180.
equals 180.
And then you add your like terms.
Add like terms. You got a lot of them on this one too. Let's see. I'll start at that 89. I've got 1. I've got 20.
110 plus 5x.
Yes. Yes. So 89, 1, and 20 gives me 110.
That's not the look like.
And then 3x plus 2x is 5x.
Yeah.
Equals 180.
Equals 180. Yes.
Yeah.
Then you subtract 110 both sides.
Good, subtract 110 on both sides.
5x equals 70.
5x equals 70.
Then you divide 5x both sides.
Good, 5 sides.
Equals x equals 14.
Yes, x equals 14. Very good. Figure number 11.
Voila.
Okay, we're done with angles. Done with angles.
Angles be crucial sometimes.
Yes. Before we move on to page 4,
Oh, see, that's
do
good.
we have any questions about these angles here? Any questions at all? See a few people still looking up and writing. I'll give you guys another minute or so if you need. And just looking ahead, the next page we're going to be looking at midpoint and distance. So if you have those formulas written somewhere, start looking for them. Should be from yesterday's notes. We may have also done a sticky note somewhere.
Yeah.
Go ahead to page 4. So on page 4, did you still need that?
Yes.
Oh, which? 11. Plus 20 plus 1. Yeah, that little 1 is sneaky. Okay, perfect. All right, so on number 12, it says find the midpoint of the line segment below and label it on the graph. So I really would like to see that you put it on the graph after you find it. I'm going to underline that and actually I'm going to circle it. Label it on the graph. I'll show you how I want you to do that. So first we need the midpoint formula. And I'm going to put that on a sticky note. So I have it. A midpoint. Midpoint. So I know that I'm not doing distance, I'm doing midpoint here. So my midpoint formula is start with a big parenthesis, and I know I'm going to add something and divide by 2, comma. Another thing I'll add 2 numbers, divide by 2, close the parenthesis. Now, if you've got that formula out, what are the 2 things I'm adding for my formula?
The X and Y, X1,
Uh-huh.
X2,
Good. X1 plus X2 divided by 2.
and then Y1 plus Y2.
Good. Then Y1 plus Y2 divided by 2. Okay, so that's my midpoint formula. So I've got 2 points labeled on here. So these are your coordinates we're using. Believe it or not, it doesn't matter which one you choose as your 1 and 2, as long as you are consistent with how you plug them in. So I'll just start with 2, 4, because it's the first one I pointed at. What would I label 2 as?
X1.
X1.
Yes.
And so 4 would be
Y1.
Y1. So now -5 is
X2.
X2.
Y2.
And then yes, -3 is Y2. So with all of that in mind, I'm going to move that sticky note a little lower so I have room to write. What are the first two numbers I will add together?
-5 plus 2.
Yeah, I've got my -5 and my 2. I could put them in either order as long as I keep track of my signs. I'm going to start with x1 to match my formula. x1 is 2 plus x2 is -5. And we divide by 2. How about my other one?
4 plus -3.
Good. 4 is y1 plus y2 is -3. Same thing, we'll end up dividing by 2, so I'll write that in. Now it's all plugged in.
So the first one is gonna be -3
Yes.
divided by 2.
2 plus -5 is -3. Bring down, divide by 2.
Second one's gonna be 1 divided by 2.
Good. 4 plus -3 is 1. Divide by 2. And you will get decimals. That's fine.
So it's gonna be -1.5.
Mm-hmm.
The second one's gonna be 0.5.
Good. 0.5 is 1 divided by 2. And so, make sure you put that in a coordinate. Parentheses and the comma. And we will circle it. That's our midpoint.
Okay.
And I'm going to write a big note under this. Label
Okay.
on graph. So the way that we label this, if my x is first, my x is -1.5. Let's look for the x-axis. That goes from left to right. Where will I go on the x-axis?
1 between -1 and -2.
Yeah, right between -1 and -2. So that would be -1.5, just about on the x. And then where do I go up or down for the y? You're going to go up. How far up? About half a point, so not all the way to 1, about halfway.
It's gonna be in the line.
So it'll be right about here. That is my midpoint. And we can tell we did it right because it looks like the midpoint. It looks like it's right in the middle. And just right. As long as you have it written and circled over here, it's fine. You don't have to write it on the graph, but I'm going to do it just for good measure. -1.5, comma, 0.5. That is number 12. So don't forget to label your graph. Put your point on there. Okay, guys, we're almost there. I think we have 3 questions left, and then all that's left is a bonus. Can I move this down a little? Anybody still need to see number 12? Yes, no?
You can go ahead.
Okay, I'm gonna go ahead. So number 13, we're doing midpoint again, so same formula. Might feel like a silly step, but you're gonna do better if you label your points. So let's label them first. How do I label 8?
It's gonna be F1.
X1. -9 is
Y1.
Y1. 3 and 3. X 2 and
Y2.
y2. Good. Okay. Same process. We're just going to plug those into our formula. Yes. So I'm going to start parenthesis. 2 with a plus. And which two numbers do I add together first?
Y8.
Good. 8 plus 3. And for my y,
-9 plus 3.
-9 plus 3. And we're going to divide both by 2. Good. That's -9 plus 3. Okay, so it's all plugged in. Now what?
You add together,
Add together.
would be 11 divided by 2,
11 divided by 2.
and -6 divided by 2.
Good. And then -9 plus 3. Yes. -6 divided by 2.
So that's gonna be 5.5
And negative 3.
Good.
-3.
So 5.5 -3 in parentheses with a comma and circle your answer. All right, back to be on the last page. Leave that up for just another minute or so.
Oh, I got a passion. Real bad right now.
We're out today. Okay, last two. Now we are finding the distance between each pair of points. So I'm gonna take a note with the distance formula. And this is the one with the big square root. We will go over how to do that on your calculator again. And be equal. Now remember, distance is the one where we are subtracting the x1 and x2, y1, y2. So we need to make a note of that. Do that. All right, subtract up here. And we have a big square root. And inside our square root, good. X1 minus x2 squared plus
Y1. And
perfect y1 minus y2 squared. Okay. Plugged in. So looking at number 14, we have two different points. Let's label them. I'll start with the one on top. You could start with the bottom. You will get the same answer. How would I label -1?
X1.
Good. X1
Y1.
and Y1 for -2. And then 3, X2,
Y.
and -4 is Y2. So let's start plugging it in. Big square root. What goes first? -1 is x1 minus x2 is 3. Close my parentheses. Squared plus
-2
Yes, -2 is y1
minus -4.
minus -4 is y2.
Squared as well.
Squared as well. Good. Now, you might already notice something that's going to happen with the y's since we've got a minus negative. We'll get there. We'll start with our x's. -1 minus 3.
-4.
-4. So, -4.
The square root is 16.
And that's squared. It will give us 16. I'm going to leave it as -4 squared for now and get my y's. Now I need -2 minus -4. What happens with that minus negative?
2
Yeah, it's really -2 plus 4,
Yeah,
which gives us, you said 2, right, Diane?
yeah.
That's right. -2 plus 4 is positive 2. Squared. Okay. So we got that. And Charles, you said -4 squared is positive 16.
Yes.
And that is correct. And what about 2 squared?
4.
4. Don't forget, we still have a big square root on steps. Yes.
-1 plus.
I know. It's -1 minus 3. We are doing x1 minus x.
But minus plus minus equals. No.
So right here, if I do
No.
-2 minus -4, I get +2, -2 plus 4. Same thing.
This is -3, -16.
Yes.
The subtraction anyway, it was a positive.
So, yes,
But
because x2 is positive 3.
Yeah, it should just be positive. If you look at the paper,
Yeah, look at our paper.
there's no.
Yeah, we just have to.
So-
Thank you, Sky. You're so helpful. Okay. So what do I do now?
take that.
16 and 4 give me 20. So my last step.
Is to put this 2 in D, put it in the calculator.
Yes, we want to do our 20, and we're finding the square root.
Yeah.
And remember, guys, the way that we do square root on our calculator, if you need to write a note, for square root, we do second, the blue button, and then we do the x squared button. And that is to give us our square root. And would it be 4.72? Yes, perfect. Square root of 20, 4.472. I feel like the square root of
That's 4.4. Yeah,
I've done it, you know. 10 times 10 is 100. Oh, that part. Yes. So think about what the square root means. It means we're finding what number can I multiply to itself to get 20. Well, apparently 4.472 times that 4.472 gives me 1. Interesting. And it makes sense if you think about it like 4 times 5 makes 20. So it has to be something in between 4 and 5.
4, 5, over 5, 6, 7. Sorry. Had to have that in there.
Okay, so you only need 1 or 2 decimals, but I'm gonna put 4.47, I think, yeah. 4.47. And I always appreciate you circling it. But, if it's on a line, I should find that one a little easier. And that was number 14. And we just have one left. One left. I appreciate you guys powering through. I know we normally take a break about 5 minutes ago. But let's power through so we don't need a break and you guys can just be done.
And we'll, winning.
Okay, so now I'm gonna leave this where you can still see 14 in case anyone needs it. And let's look at 15, our last one. The bonus is right below this. If you want to stay to watch us do the bonus, you can. However, if you are somebody that does not want to do the bonus, it is completely optional. So for number 15, let's label our points.
Yes.
3 and 8 will be
X1.
X1, Y1, -4, 0, X2, Y2. Okay. And we're going to plug in to that distance formula. Okay, so let's see.
X1.
Is square root. Let's see. 3 minus. What goes in first? 3 minus
-4.
-4.
Plus
Don't forget the square.
square.
That's plus
Alright. 8
8
minus 0.
minus 0.
Square.
Square. Good.
4.
Okay. So 3 minus -4, what's happening there?
7.
Addition. Yeah, that turns into a plus. So it's 3 plus 4 is 7. Square. Good.
Plus
8 squared.
Plus, yeah, 8 minus 0 is just 8 squared. Bring down my square root so I don't forget about it.
after that's 49.
Mm-hmm. 7 squared is 49.
Plus 64.
Plus 8 squared is 64.
113.
Good. 4 times 64 give us 113.
Square root of that is 10.63.
Hey, yes. Second square root 113 equals 10.63. So D equals 10.63. There you go. Okay, and that is all of it, other than the bonus. So if you are happy with just this part, you really are free to go, unless you want to stay for extra practice or other things. I'm going to leave this up for just a minute, and in just a second, we will go down to that bonus question. Give it another minute here. All right. Here is an example of what your bonus question might look like. It says, bonus, draw a picture that represents the situation. Solve for x, the length of AB, I gave you all those here, the length of BC, and the length of AC. So here's the situation. A segment, a line segment, AC, contains a midpoint B. So that means there's a line segment from A to C, and in the middle there's a midpoint. That means something about the length. So let's start with just that. I'm gonna do my picture on a sticky note, so I have space to do my work. So if I want to draw a segment AC, what does that mean? How could I draw that and label that? To draw a line segment, yep. And if it says it's named AC, what does that mean about how I label my points?
Both first.
Yeah. The first point will be A, the last one will be C.
One in the middle into B.
Yes, and then it says contains a midpoint B. Now, it doesn't just say contains a random point somewhere on the line, it says a midpoint. What does midpoint mean about where it needs to be?
Middle.
Exactly in the middle. So the two line segments that are created could be equal. So it doesn't have to be perfect. But mine's about 2.5 inches, so about 1.25 inch. That would be about my middle. So there's point B. And how could I show that this is a midpoint? We do this on the perpendicular bisector. How could I mark this to show these are equal?
The ticks.
The tick marks. Yes. So put tick marks on there. And even if you don't do the math, you will get a bonus point just for drawing the picture right. So there you go. There you go. Now it says if AB is equal to 3x plus 10 and BC is equal to x plus 12, what is x? And then what is the length of all of these? So here's how we can do that. It says AB is 3x plus 10. Circle, it says BC is x plus 12.
So basically write your own equation,
Yeah.
following that thing.
Yeah. So what could I label 3x plus 10 on my picture here to kind of help me?
Between A and B, so the 3x plus 10.
Yes, between A and B, that's 3x plus 10. I'm just going to start by labeling that. 3x plus 10.
B and C is x plus 2.
Yes.
12.
Between B and
On the
C
other
is
side.
x plus 12.
Question.
Yes.
Will it equal 180?
Now, these are not angles, so we don't know what they equal. We don't know that, but that's a good idea. I bet you were thinking that because this is a straight line.
Yep.
So it could be 180. I see what you're thinking. Smart.
He's looking at the finger.
Yeah. He's
Okay.
thinking ahead.
Uh-huh.
So the difference between this and something like our segment addition postulate is normally we're given values and a total length. I don't know the total length, but I do know, based off of some markings that I put on my picture, how these values are related to each other.
Like turn.
Not yet, not quite yet. We still need to make an equation first.
Yeah, so then we in the middle.
AB and BC does equal AC. That's gonna be true. But I don't know what AC is, do I?
You combine it together.
Could combine them together. I'm throwing something at you that we haven't done.
We need to put the equal sign in the middle, don't we?
Diane, yes. Yes. Say that again.
We need to put the equal sign in the middle.
There's gonna be an equal sign in between these two values. Why is that?
Because we're separating the two equations.
Yeah.
Well, we are gonna separate the two equations, but how do we know they're equal?
The ticks.
The tick marks. And we know that it's a midpoint, so these are equal to each other. If it's in the middle, these are equal. So that means we can just write 3x plus 10 equals x plus 12. Okay. Can I solve for x now?
Yes.
Yes. Okay, so I'll draw a line down the middle. How do I get my x's together?
Math, like turkey.
Yes, let's do the math. We'll subtract x from both sides.
2x plus 10
Good. That leaves me with 2x plus 10
equals 12.
equals 12.
Then you subtract 10 both sides.
Good. Subtract 10.
2x equals 2.
2x equals 2.
And divide 2 both sides.
2.
X equals 1.
Yes.
It took off. on-
Yeah, I love it when he does that. I mean,
1.
Smooth.
Good job. Okay. So now I know x
Right,
is
I'm telling you.
1.
Yes, that's the answer.
So over to the side. Hang on, let me move this. You guys will still be able to see it. Yeah. Put it over here. So these are the things we needed to answer. X is 1.
AB is 3x plus 10.
Yes. Now I know AB is 3x plus 10. How can I use 3x plus 10 and now I know x is 1? Can I use that to find the actual number length of AB?
Yes.
You can. We're going to plug the x in. Okay? So over to the side, now I'm going to find AB. I know AB is 3x plus 10. And x is 1. So let's just plug it in. 3 times 1 plus 10, right? You see what we did? And what do I do now?
3 plus 10.
Yeah, 3 times
Plus
1
you
is
multiply
3
the-
plus 10.
13.
80 is 13.
So
So that's our answer for the next part. AB is 13. Now, if AB is equal to BC, do I really have to plug it in a second time? No, you don't. You can if you want to just be doubly sure. But if I plug in x plus 12, 1 plus 12 is also 13. So that works.
So AC is 26.
Yes, AC is the whole thing. AB plus BC is AC. So 13 plus 13 is 26. We see how we got that?
Oh, okay.
So AB plus BC equals AC. We're wanting an equation. AB is 13 plus BC is 13 equals AC, and that's 26. So that would be our answer. That's our bonus question. There we go, y'all. So, that is all we are doing today. If you're not completely finished or if you need to go back and see other problems, I will have this copy available to anybody that wants to see it. And that's all we're doing today. So, if anybody wants a blank copy of this to maybe quiz themselves at home, or if you need any extra practice, come and see me. I'm sure I can find something for you. But that's all. So you guys are free to go, and we're going to take that quiz tomorrow.